Alright, so we're ready for the grand finale of this test. We have 3 true and false problems to work out, and we get to use the mod magic tricks that we found earlier in the test. So first up, divisible by 36 means we're searching for a remainder of 0 in mod 36. So the trick that we thought of for 36 was to use 4 and 9's trick. So the first thing we can check, let's just call our number x to be convenient. So x is congruent to 56 in mod 4. And 56 is in fact a multiple of 4. So that's 0 in mod 4, or our remainder is 0. So the next thing that we need to check is adding up all the digits to see if that works as well. So let's notice the pattern here of 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So it seems like some of those numbers are repeated and they're jumbled up in a different order, but that's not a problem. So we can order them however we like because we're just adding up the digits. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. Notice that those exact same digits are jumbled up at the beginning of our number x here of 1, 2, 3, 4, 5, 6. So x is congruent to twice as much as that number that we've just written down. Okay, and we get to reduce this one in mod 9. So let's remember that all the 9's actually make 0. So 4 and 5, that makes 0. 6 and 3, that makes 0. So we're not left with too much. So we're left with 2, 1 plus 2, or 2 times 3, which is 6, but it's not congruent to 0 in mod 9. So did this work out? No, it's just not divisible by 36. So this one is false. Okay, next up, we're supposed to take the exact same number and check for divisibility by 63. So this time, our test that we found earlier on is to check the addition of groups of 6. So our number x can be broken up so it's 4, 5, 6, 1, 2, 3, plus 1, 2, 3, 4, 5, 6. And this should be a job that our dinky little calculator can handle. So 4, 5, 6, 1, 2, 3, plus 1, 2, 3, 4, 5, 6 equals this number. So it's 5, 7, 9, 5, 7, 9. And we want to know what happens with this number when we divide by 63. It turns out we do get a remainder of whatever here, because we can figure it out by subtracting 9199. So 9199. Subtracted away gives us this, and multiplied by 63 gives us 42. So the number that we're given here is just also not congruent to 0 in mod 63. So it's not 0 is the point. So this one is also false. Let's check out the last one. Okay, in this problem we're supposed to let a, b, c be integers. A, b are both smaller than c. A divides c, or is a factor of c. B is a factor of c. Is that enough information to conclude that AB is also a factor of c? So probably the best way to start here is just think about plugging in some numbers. And A is a factor of C, B is a factor of C, could tell me that, if A and B are small enough that, maybe the AB when multiplied wouldn't be, too big, so it could still be a factor. But it doesn't tell us that A multiplied by B is a certain size. It just tells us that A is less than C individually and B is less than C individually. So when I look at this, I'm still kind of nervous that the A and the B might be too big, or it could be bigger than the C. So maybe try to come up with an example along those lines. So 4 is a factor of 8, and 4 is a factor of 8, but 4 times 4 is 16 is not a factor of 8. So this one is also false. So it turns out that all three of these are false.